In this part of 1.3, we will apply the distance formula to find the length of a segment when given the coordinates of the endpoints. First, let's discuss length of a segment versus distance between 2 points. Really, it's the same thing. Length means the measurement of the distance. The length is the measurement of the distance between 2 points. And distance is just length. Now, technically, distance is the absolute value of the difference between the coordinates of the endpoints, or in this case, the absolute value of the difference of the coordinates of A and B, since A and B are the endpoints in our picture. Well, what does all of that mean? I'll show you. Really, the most important part to remember is that length means distance, distance means length. There's just different ways to describe it. I've grabbed my ruler so I can measure the length of this segment. Notice when I get my ruler, I mark the end of the segment at the 0 part of my ruler. 0 isn't always at the very end. And if I mark it at the 0, I see that the B lands at about the 60 unit mark. So if I wanted to mark how long this is, I could mark it on the picture exactly, 60 units, right in the middle of the segment, or I could mark it nearby the segment and say AB equals 60 units. That's the length of the segment with endpoints A, B. Now, I could do that, or I could find the coordinates of those points and mark it by marking it anywhere on the ruler. So if I don't start at the 0, but let's say I start at the 20, like that. So notice that the A is at coordinate 20 and B is at coordinate 80. Coordinate really just means a position. So I'm going to move those a little bit away so that I have room to write that A is at the unit 20 and B is at the unit 80. Well, that doesn't mean that AB is 80. This is the same segment as the previous one. But how do I find the length this time if I didn't start at 0? So I calculate from A to B. It's the absolute value of the difference between the coordinates. Remember, difference means subtract. So 80 minus 20, and I'm going to put the absolute value because we said it's absolute value, but because 80 minus 20 is a positive number anyway, I don't really need them. It's 60 units. Now, if I did it the other way, AB equals absolute value of 20 minus 80, then I need them because I get negative 60 and absolute value will make it positive 60. Either way, I'm finding the distance is positive 60, which was the same as the length. The length is 60 units, so the distance between points A and B is still 60 units. Now think about when you need to compute length and jot down that idea on your paper. When in life do you need to calculate distance or length? Remember, distance and length, same thing. Think of an example, jot it down, pause the video, come back when you're ready. So let's take length a step further. Do you remember the Pythagorean theorem? Why are we talking about Pythagorean theorem now? Well, remember that this is a special formula for finding lengths. Now, not just any lengths anywhere, anytime, but specifically for finding lengths of sides of right triangles. So I showed you a picture of a right triangle. Here's the right angle of the triangle. That right angle is pointing like an arrow to the hypotenuse. The longest side is called the hypotenuse. Remember that? Do you remember what the other two sides are called? That's right. That's a leg and that's a leg. Now I labeled the legs A and B. Doesn't matter if this one's A and this one's B. It could be like this. as long as the hypotenuse is the one we call c. And then the formula, c squared equals a squared plus b squared. Again, the letters can be anything. The important thing is it's hypotenuse squared equals leg squared plus leg squared. Now, why are we talking about triangles now when we're discussing lengths? Let's look at it. Here we're going to practice finding length or distance in a coordinate plane. Like number 1, find the length of the segment with these endpoints. P is 0, 2, R is negative 4, 5. Now, what's another way I could have asked this question? How about find the distance between points P and R? I could have said that. Remember the most important thing here, distance and length mean the same thing. It's just a different way to ask the question. Now, we're going to start by doing this with a graph, and we're going to plot these points in our coordinate plane. So I'm going to show my y-axis. Now, I see some negative for the x value, so I'm going to put my y-axis with enough space so that I have room to show the negatives. X-axis can go low because I don't seem to have any negative y values. Now I'm going to plot point P, 0, 2. So remember how we look at this. The x comes first. This is x1 and y1 and x2 and y2. So first I'm going to graph 0, 2. The x is 0, so I don't go over any, and the y is 2, so I count up 2. And I'm going to write next to that point P to label it. R is negative 4, 5. So I'm going to count from the origin, 1, 2, 3, 4 in the negative direction, 1, 2, 3, 4, 5 in the positive direction, and put point R there. Now I'm going to connect those with a segment, since it says in the directions find the length of the segment. Now we can pull out our right triangle knowledge. How? I don't see a triangle in here. But yes, if we travel from one point to the next by only following the grid lines, we will make a right triangle. See what that looks like here? That is our right triangle. Here's the right angle right there. We could call this our A, this our B, it's our legs, and the hypotenuse is our C. Now when it's slanty, we can't just count how many units that is, but when they follow the grid lines, we can. So along the x direction, 1, 2, 3, 4 coordinates that way, and in the y direction, 1, 2, 3 coordinates that way. So if I'm using my Pythagorean theorem, c squared hypotenuse squared equals one leg squared plus other leg squared. And how do we solve this? Well, I could square these first, so c squared equals 16 plus 9, then add them together, and then I need to make the squared go away, so we take the square root. So it looks like c equals 5. Now remember my ultimate question was how long, what's the length from P to R? PR equals 5. There's our answer. But counting on the grid lines isn't always the most efficient way to solve these problems. Sometimes we don't have a graph to count. Sometimes the graph might be too big to count. So that's when we pull out the distance formula. But oh my gosh, I need to learn another formula? Not really. Distance formula is just Pythagorean theorem kind of disguised. Here's what I mean about that. If we take our Pythagorean theorem, c squared equals a squared plus b squared. Now remember the last step we did where we needed to take the square root to get rid of the squared. Well, I don't want that squared ever to be there. So if I take the square root of both sides, now it's gone. So here's what we have left. C equals the square root of something squared plus something squared. But remember how we got those somethings? We counted the distance. We counted the distance in the x direction and the distance in the y direction. And remember what distance means? Let's look back. Finding the difference between the coordinates, subtracting them. So going back to our problem, if I want to find the x distance, which would give me my a squared, right? I want to find my x distance, and then I want to square it. And I want to find the b, which is my y distance, and I want to square it. How do I find those distances? We subtract. Take the x's and subtract them. So ultimately, x distance will be from x2 minus x1. Y distance will be from y2 minus y1. Take the coordinates and subtract them. So here's what the distance formula ends up looking like. We say d for distance equals the square root x2 minus x1 squared plus y2 minus y1 squared. Nothing different than the Pythagorean theorem, just another way to look at it. Now, this ability to find distance, whether you know it with the distance formula or Pythagorean theorem, is extremely important. So perhaps you highlight, star, something to that formula. Now let's practice using that formula in case we didn't have a picture. Now d is the distance, but in this case I know the endpoints. So I'm going to write PR equals square root. Now let's look at the x coordinates. The x coordinates are 0 and -4. So I'm going to do the -4 minus 0 and square it. Plus, now it's the y coordinates. So I'm going to look at the y coordinates, 5 and 2. So 5 minus 2 and square it. Now let's simplify that. Don't forget to keep writing square root so you don't forget to take it. -4 minus 0 is -4 squared. Notice I keep the parentheses. Always keep them. 5 minus 2 is 3, so 3 squared. We just want to be in the habit of keeping them because when it's negative, it's needed. -4 times -4 is 16. Don't forget the square root. 3 times 3 is 9, and 16 plus 9 is 25. So ultimately, square root of 25, which I can take because 25 is a perfect square, and get 5. See how much easier that is when we don't have to use a graph? So maybe from now on we try the distance formula. It's just subtracting, squaring, adding, and the last square root step. Let's try another one. Find the distance between the points 1, 2, and 5, 4. Now it's your turn. I want you to tell me another way you can ask this question. What could you have said instead of find the distance between these points? Write down what you think is the way you could ask that question there. So back to the question. Finding the distance between those points. Let's remember the distance formula, or let's think about this logically. Now I'm doing it between points M and N. So I'm going to write MN equals, I know my distance formula has a square root. I look at my x coordinates and I subtract them, 5 minus 1. And I will need to square it. Plus, now I look at my y coordinates and I subtract them, 4 minus 2. And I square it. Now let's simplify. Square root of 5 minus 1 is 4. 4 squared becomes 16. 4 minus 2 is 2, and 2 squared becomes 4. Add them together, we get 20. Now, unlike the other question, 20 is not a perfect square. If I tried to type square root of 20 into my calculator, I get a decimal. It's about 4 point something. But we usually want to give our answers in nice simple forms, not answers where we have to round them. So let's practice breaking down this radical. We ask ourselves, what perfect square divides evenly into 20? So think about your perfect squares. 1 times 1 is 1, but that goes into everything. 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16. 5 times 5 is 25. Now this is too big. So let's start with the smaller ones. Does 16 divide evenly into 20? No. Does 9 divide evenly into 20? No. Does 4 divide evenly into 20? Yes. 20 divided by 4 is 5. So I'm going to rewrite this as square root of the perfect square 4 times 5. Square root of 4 is 2 with a 5 left over. So here's my best answer, mn equals 2 square roots of 5. Now, just to practice graphing, just to check, let's go ahead and draw our y and x-axis and just check our work from this problem. So m is at 1, 2. From the origin, over 1, up 2, and that's point M. N is at 5, 4. So from the origin, 1, 2, 3, 4, 5, 1, 2, 3, 4. And I'm going to connect it and find that length. Now, the check way is make a triangle. Follow the grid lines, like that's the only part you can walk on, and count how far you went. 4 blocks and then 2 blocks. Then this becomes a Pythagorean theorem. C squared equals 4 squared plus 2 squared. So C squared equals 16 plus 4, or 20, and C is the square root of 20. Simplifying the radical gives us the same 2 square roots of 5. That worked out. Finally, we'll apply the distance formula. Are the following segments congruent? Explain how you know. MN has endpoints M and N, 0, -4, and 5, 8. ST has endpoints. S is -1, 2, and T is 11, 7. It doesn't say find the distance. It doesn't say find the length. It asks, are the following segments congruent? What does congruent mean? That's right. Congruent means has the same length. So how do we find length? With the distance formula. So let's do that for each of these. Let's start with MN. Now I'm finding a length, so I'm going to write it without the hat. MN equals, and I'm going to look at the points for M and N. Remember the square root. Now we start with the x's and subtract. The distance between the x's is when we subtract. Then we'll need to square it. Plus, now look at the y's and subtract. 8 minus -4. Now remember, that's really like saying 8 plus 4. Let's simplify that. 5 squared plus 12 squared, and that's 25 plus 144, or 169. So take the square root of 169, 13. MN equals 13. Now let's find out what ST equals. ST equals, put our square root. S is here, T is here. Look at the x's first, 11 and -1. 11 minus -1 plus 2 and 7. So 7 minus 2. Now let's simplify. 11 minus -1 is like 11 plus 1, so that is 12 squared. Plus 7 minus 2 is 5, so that's 5 squared. Now before I give myself too much work, I notice I saw 5 squared and 12 squared earlier. Because this is the same as that, I know I'm going to get the same answer, 13. So saving myself some work, I see ST is also 13. So yes, they are congruent. Now let's explain how we know. MN equals 13, ST equals 13. That was from the work we just found. That means MN equals ST, the lengths. Therefore, MN, segment MN, is congruent to segment ST. Perfect. Now, since we're talking about lengths, go ahead and practice again copying segments. Visit this website for step-by-step instructions, proofs, and extra practices. That's for copying a segment. It's pretty fun. Finally, your summary. Describe how the words distance and length can be used to ask the same question two different ways. How are the words distance and length like each other? Have fun, and I'll see you in class.